This is the review for the quizzes that we did in class for Prob Stat. I wanted to go through each of the questions and show you exactly what needed to be calculated in order to get the correct answer. I have my graphing calculator on the computer right here, which hopefully should be helpful in regards to solving these problems. Let's see what happens. Number one. The American Red Cross says that about 11% of the U.S. population has type B blood. A blood drive is being held at your school. What is the probability that exactly 2 of the first 20 donors have type B blood? Now, this is, I think this is the exact problem that we did in class on Monday on a worksheet. But regardless, let's talk about it. This is a binomial problem. The reason why is because you were looking to get exactly 2 successes out of 20 trials. There is a set number of trials, and you're looking to get that many successes out of it. Now, being that it's a binomial, it is also a binomial PDF because you're getting exactly that many successes. So on the graphing calculator, second vars, binomial PDF, there are 20 trials. I already forgot the probability of success. In this case, 11%. Let's see. 0.11. And you're looking to get exactly 2 successes. So what I would write down, again, if I was doing this for an assessment or something along those lines, I would literally write down what I have on the screen right there and the number that ends up being calculated as a result, 0.282, which you can see is indeed the correct answer. Moving on to number 2. Now, this problem, same exact situation, except at least 2 of the first 10 blood donors. Now, being that it's at least 2, meaning 2 or more. Now, this is a weird situation. It sounds like a binomial CDF, and it is. However, when you do CDF on the calculator, it calculates that many successes or less. This problem is saying at least 2, meaning 2 or more. What I need to do is this. First, let me bring up a binomial CDF. There it is. I believe there are 10 trials, 11% chance. Now, again, the x value, whatever x value I put in here for the number of successes, it would be that many successes or less, being that it's a CDF. I'm going to put in a 1 because calculating this binomial CDF will get me the probability of 1 or less successes. Now, that is not the answer to the question, obviously, because this one wanted 2 or more. And you can even see the number that I got is one of the choices. Since I need 2 or more, and this number represents 1 or less, I do 1 minus that calculation. You can see 0.303 is indeed the answer. That is getting the complement in order to get the correct answer. Number 3. When rolling a fair die 100 times, what is the probability of rolling a 4 exactly 25 times? This is another binomial problem. There are 100 trials. There are 25 successes that we're looking to get. And now rolling a 4, well, there's a 1 in 6 chance of getting that 4. This is a binomial PDF. Binomial PDF, 100 trials. There's a 1 in 6 chance of getting that 4, and they want exactly 25 successes. Write that down to show my work. That's what I ended up calculating in the calculator, 0.009, which technically rounds up to 0.01. There it is right there. Number 4. Is this a binomial experiment? You shuffle a deck 52 cards. You turn over the top card, you put the card back into the deck, and you shuffle again. You repeat the process 50 times. Let X be the number of aces that you observe. Now, right off the bat, let's just talk about the probability of selecting an ace. There is a 4 in 52 chance that you would select the ace in a deck of cards. Now you're shuffling, which is randomizing everything. You select a card. It could be an ace. It could not be an ace. It doesn't matter. You end up putting the card back, thus resetting the probability back to 4 in 52. If you put that card aside, all of a sudden that 4 to 52 chance would change. So since it stays a 4 out of 52 chance, then the trials are what we call independent of each other. Yes, this is a binomial experiment. You have a set number of trials, 50, and X is just the number of successes that you're looking to get. And there's a 4 in 52 chance, which is your probability of success. Which of the following is not an assumption for a binomial distribution? Well, as we just talked about right here, all trials must be independent. Yes, that one must happen. Which one is not an assumption? Each trial must be classified as a success or failure. Yes, it must be. Thus, the idea of binomial. All trials are dependent on each other. Now, that contradicts the first statement. That clearly should be the answer, but let's just read the last one. The number of successes in the trials is counted. Well, yes, of course it is. This is the only one that is not an assumption. Number 6. Which of the following trials is geometric? Now, before I even read any of them, what I've described to you about being geometric is that they're looking for a first success. One at a time. The number of text messages until you get one from your mom. Okay. The number of text messages that your mom sent. The number of times the phone rings in a day. The number of texts in a row that your mom sent. It's got to be this one. Obviously, getting a text message from your mom, I don't know if you want to count it as a success or failure in real life, but it's what we're looking for, getting that first success until you get that one from your mom. That is a geometric. Number 7. The local Chipotle is running a promotion where each large drink cup has a large pull-off tab that reveals a prize, free burrito, or the message, try again next time, wah wah. Chipotle claims that 25% of the cups have tabs with a prize. You visit Chipotle to try to win. What is the probability that you win on your third visit? First, identify what type of probability this is. This is a geometric because you're looking to get that first success. What is the probability that you win on your third visit, implying that you failed in your first 2 visits? 25% of the cups have a prize, meaning 0.25 is your probability of success. Now, since you're looking to get the win on your third visit, it sounds like it's exactly that visit. So this looks to be a geometric PDF. You have a 25% chance of victory, and you're trying to win on your third attempt. Like 14%, or 0.141 if you want to round it. Go back to here. There you go. 0.141, which rounds to 0.14. Yep, there it is. Number 8. The American Red Cross says that about 11% of the U.S. population is type B blood. Now, we've done this one before. What is the probability that the 10th blood donor is the first one with type B blood? That is a geometric. You're looking to get that first success on the 10th blood donor. Now, it's exactly the 10th blood donor. So, again, it seems like a PDF. PDF is getting it on exactly that try. Now, 11% chance getting it on the 10th trial. Let's see. Looks like a 0.039, give or take. 0.039. Yep, and there indeed is the answer that we're looking for. So, for number 9, a September 2011 Gallup survey suggests that 38% of Americans are planning on voting for Barack Obama in the 2012 presidential election. Among a random sample of 100 people, approximately how many would you expect to vote for Obama? Now, this is a formula that I gave right before the quizzes, where it was the expected number within a binomial. Well, if there are 100 people, and the survey suggests that 38% of them are going to vote for Obama, 100 times 0.38, I don't even have to bring up the calculator for that, 38 people. This is a binomial problem because you have 100 in the trial, a probability of success, and you're not looking to find out the probability of however many people ended up doing the thing that you were looking to do. It was just how many successes would you expect to happen? Number 10. A test consists of 10 multiple choice questions with 5 choices for each question. Okay, I'm just kind of putting that together in my mind. As an experiment, you guess on each and every answer without even reading the questions. So because there's 5 choices, you have a 1 in 5 chance of success. What is the probability of getting exactly 6 questions correct on this test? There are 10 trials. There's a 1 in 5 chance of success. You're looking to get exactly 6 successes. This is a binomial PDF problem. Let me bring up the binomial PDF. 10 questions, a 1 in 5 chance, getting exactly 6. 0.0055. Now, I think this one had a little bit of a typo, actually. Oh, no, it didn't. No, it didn't. 0.0055 would be 0.06. See right there, round. No. I'm sorry. What am I doing? Let's bring that back a little bit. It would be 0.006, which you converted it to a percentage would be 0.6%. Yep, there's no typo here. Nice. Number 11. The owner of a pet store is trying to decide whether to discontinue the selling specialty clothes for pets. Ridiculous concept. She suspects that only 4% of the customers buy those clothes. 4% chance of success. The owner had 275 customers that day. Assuming a typical day, what is the mean and standard deviation? Now, I apologize for this one because I said not to worry about the standard deviation. But the mean would be 0.04 times 275, which would be the expected number of successes. And I apologize. There is a way of calculating the standard deviation, but I am not going to assess you guys on that for this problem. I'll just show you the answer here. It should have been that one. So if you picked this one or the other 11 customer one, I'm not going to fault you on that. That's probably where the thing messed up. Whatever. Anyway, number 12. If you flip a coin 20 times, what is the probability that you get at least 13 heads? Flipping a coin is a 1 in 2 chance. 20 trials. This sounds like a binomial. Getting at least 13 heads, meaning 13 or more, well, that sounds like a binomial CDF. And it is. But what do we do here? There are 20 trials, 1 in 2 chance of success. Now, it says at least 13 heads, meaning 13 or more. But binomial CDF does or less. The way we do this problem correctly, I can't do 13 or more, but I can do 12 or less. If I do 12 or less, it gets me this And in order to get 13 or more, I simply have to do 1 minus that answer. Oh, try that again. 1 minus that answer, which would be the complement, 0.123. You can clearly see is the answer. Number 13. If you were to flip a coin 20 times, what is the probability that you would get at most 13 heads? Now, at most, 13 would mean 13 or less. It's almost the exact same calculation, except I can put a 13 here because this binomial CDF will indeed calculate 13 or less, 0.942, which you can see is indeed the answer. Number 14. Suppose that 39% of Americans will vote for Donald Trump on Election Day. If a random sample of 8 voters were selected, what is the probability that more than 5 will vote for Trump? Now, more than 5, I'm assuming would be 6 or more. This is a binomial CDF. Let me bring it up and let's try to type in some information. This is a binomial CDF. There are 8 voters. There is a 0.39 chance of success. Now, this problem wants more than 5, meaning 6 or more. So I'm pretty sure I'm going to have to put a 5 here to calculate 5 or less. Then I would do the complement in order to get the answer for 6 or more. 0.044, yep, is indeed the answer. Finally, number 15, 45% of some high school students are male. If you randomly choose 50 students, what is the probability that a male will be chosen in the first 5 students picked? Well, it could either be picked first, he could be picked second, third, fourth, or fifth. Now, they're looking to get a male in the first 5 students. This sounds like a geometric. You're looking to get that first success. But since it's within the first 5, it's a geometric CDF. There is a 45% chance of success, and they're looking in the first 5 students or less trials. 0.949, which is really 0.950. There it is. It's all about the wording of the question. If you have any questions, please make sure that you are emailing me.